Good afternoon, sixth graders. It's Mrs. Nelson again. I hope you had a great Halloween weekend. We're back in science today learning about compressibility. I put the definition below, and what compressibility is, it's the measure of how much a given volume of matter decreases when placed under pressure. So let's think about it in a real world example. Think about when you're packing to go on vacation. There's always one more thing you need to get into the suitcase. Maybe it's a swimsuit, shoes, a book, whatever it is, we need to get it in. But fortunately, we can squeeze things together. There's just little space between the folds of clothing. We might be able to rearrange the shoes, and somehow we can fit that last thing in to close the suitcase. This is an example of compression. Another example is when we see scuba divers with those tanks of air on their back, it is the divers carrying their own breathing gas in the form of compressed air. So the compressed air in most scuba tanks provides enough air for divers to breathe underwater for 40 to 50 minutes. You wouldn't think it, being that the size of the tank is as small as it is, but because it's compressed air, it is useful for 40 to 50 minutes, which is a useful thing when we're underwater. This is also an example of one of the practical uses of compression, and we're going to talk today about more uses that we see in our everyday life that are helpful because the way that we can compress gas. So I've only talked about gas being compressed, and the question I have at the top here says, can solids or liquids be compressed like a gas? Can we squeeze together solids and liquids and make them fill up a smaller space? Well, here's the deal. Since the particles in solids and liquids are already so closely packed together, there's little to no space between the particles. What that means is they cannot be pushed further together when we introduce pressure to them. So, therefore, the volume of liquids and solids do not change under pressure. And I'm going to show you some examples where you can see that, in fact, the only matter that can really be compressed is gas. Gases are unlike any other states of matter in that we know that a gas expands to fill the shape and volume of its container. Because of this, gas can also be compressed so that a relatively large amount of gas can be forced into a smaller container. Compression, right? Compressed gas. It's an important concept to know too in the purple writing down here. It says when a gas is compressed, the volume of the gas decreases and the pressure increases. Let's take a closer look at that. Well, why do gases compress more easily? I mentioned this in the last slide, but let's take a look at what we know the particles in solids, liquids, and gases look like. We can see that, remember, in a solid, those particles are in an organized, fixed fashion. If we put compression on that solid, it's not going to decrease the volume of that. There's not enough space between the particles to add compression and be able to minimize the volume in that solid. Same with liquid, okay? But when we see that these gas particles are spread out and there's space between them, when we compress them, we can decrease the volume as we add pressure. I'm going to show you another example of this here. So this is just a demonstration of compressibility. And remember that that is the measure of how much a certain volume of matter decreases when placed under pressure. Okay, so right now I can see that here's a a solid in the bottom of this tube here, and I'm going to reduce the volume of the container by pulling this down. Basically, I'm just shortening the amount of volume in this container, and I'm pushing it on it and I'm compressing it, but does the solid change at all? No, there's not enough space within those particles to be able to compress. So solids do not compress under pressure. Same with liquids, right? We see the same thing happening. Those particles are too closely together that even with compression, our volume cannot decrease and it stays the same. Now take a look at these gas particles. Very spread out. Right now they're filling the volume of the container, and as I decrease the volume of the container, you can see that the gas particles are being compressed. Okay, and that's what's happening in compressed air tanks. Those gas particles are being compressed into a smaller volume. Okay. All right. I'm actually going to play a video of another demonstration using solids, liquids, and gas to show you that gas is really the only state of matter that can really change when it is being compressed.
Can matter be compressed, and how much? Does the extent to which a material can be compressed depend on its state? Let's see. We will need a syringe, chalk, and water. Put the chalk in the syringe and compress it.
Putting the solid,
It does not compress.
and it does not compress.
Now take in water.
Adding pressure.
Seal the opening and compress it.
Feeling it and pushing.
It compresses just a little.
It compresses just a little, but then you can see it kind of pops back up.
Now take in air, seal the opening, and compress it. It compresses the most.
See how it compresses? You can push down, add compression, add pressure in the gas.
The distance between individual particles in the case of gases is most, and hence it gets compressed the most. This distance is called the intermolecular distance. Gases also tend to expand and occupy whatever space is available to them. The intermolecular distance is less in a liquid than that in the case of a gas, but more than that in the case of a solid. This allows them to be compressed a little, but they do not expand, but tend to settle down in containers. Solids have the least intermolecular distance, and hence they compress very little. Gases such as oxygen, nitrogen, helium are transported in cylinders in a highly compressed state.
All right. So we talked a little bit in the beginning about scuba tanks and how compressed air is used for underwater scuba divers. There's a couple other uses for compressed gas as well. So anesthesia in a hospital, oxygen for medical needs. When we use our barbecue grill, then we use a propane tank. That's compressed propane. Okay? In welding and powering machines like a forklift. So these are just some of the practical uses for compressed gases. Right now, my lesson is finished. There is a Kahoot that is, you can click on this slide and it will bring you to the Kahoot. Remember to choose Teach and Classic mode for teachers. That way you guys can all play together and see how you did learning some of the concepts for compressibility. I hope you have a wonderful day. Take care, guys. Bye-bye.